Yo, what's up? Welcome to day 19 of IntelligenceMaxxing. So, I'm trying to get as smart as I can, I guess, and hopefully do that until the day I die. Every single day, little by little. No. But right now, I'm gonna go through some of my flashcards I have for Anki. So, these are some flashcards I have for class that I kind of want to go over. And let's see. Sync. Okay. Yeah, I think I'll just get started then. So calculating p-values when hypothesis testing. I don't know the exact way to do this, but I know there's a few different techniques that relate to statistics testing or statistical testing, t-tests, f-tests, and there's also one-sided, two-sided test. So that's something that I still need to do a little bit of review on. Chi-square test, analysis of variance, and chi-squared analysis of variance t-test. Okay, I'll put a good on that for now. But so p-value, and what does a high or low p-value mean? So I guess when we talk about p-values, what they are stands for probability value, and they're used whenever we're running experiments or hypothesis testing. And so when we think about p-values, we can think of it as we have a null hypothesis and an alternative hypothesis. The null hypothesis usually states that there is no relationship between our variables that we're experimenting with, and the alternative hypothesis usually states that there is some sort of relationship. And so what we can think about then is p-value is the probability that our alternative hypothesis is true. Not true, but we can observe our alternative hypothesis given that the null hypothesis is true. So another way of saying this is, what are the chances of our alternative hypothesis actually occurring by random chance? And so if it's a high chance that this occurs randomly, then that means that our alternative hypothesis probably it's not really true. We could probably say that, I think the statistical way to say it is rejecting the alternative hypothesis. It's likely that there is no real relationship other than chance and randomness. But having a low p-value means that we can say that we failed to reject the alternative hypothesis. I think. So that's something I should probably double check. So, failing to reject.
Aren't your early risers only awake for like 7, 8? It seems like your body voices
Failed to reject. Failed to reject the alternative. Okay. Okay. So I think it makes a little bit more sense when statisticians talk about hypothesis testing, they talk about failing to reject the null or rejecting the null hypothesis. And I feel like when we have a higher p-value, that means that we're failing to reject the null hypothesis, meaning that there's a good chance that our null hypothesis is true, but we're not 100% sure. And even with a low p-value, can we reject the null hypothesis completely? Is our alternative hypothesis absolutely true? I feel like that's also up for debate, but I think maybe that's probably why we run experiments, and there might be some margin for error. But I guess the overwhelming decision is to reject the null, and that I feel like infers that you accept the alternative hypothesis. I guess that's usually the goal of an experiment. So I think something like that. Okay. So this is fail to reject null. Rejects null. Okay. What is a good hedge against deflation? Why? Okay, so I think in this context, when you think about deflation, it's the idea of your purchasing power increasing. Another way of saying that is the prices within a certain economy are decreasing. And so to protect against that, I think what you could do is purchase treasury bonds or treasury bills or what type of government security that's denominated in that specific currency. So what I mean by this is when you have a currency that's devaluing, maybe that's not the case, but I think that, okay, yeah, I think so. Deflation, I guess, and currency devaluations are pretty similar in the sense that the value of your currency with respect to its purchasing power decreases. So in order to protect against that, you can lock in a treasury bond or a treasury bill that'll give you a fixed coupon rate or a fixed payment every month, every quarter, every semi-annual period. And those cash flows will become more valuable over time if prices are decreasing. Okay. Yeah. How are asset management firms utilizing generative AI in 2022? So with generative AI, it's kind of a buzzword nowadays, but I like to think of it as just being able to create these new ideas, new images, or new products using some type of machine learning model. And I think what it does under the hood is it uses existing data to be able to make predictions on what a new project will look like given some type of input, so an input of future vectors. And I think with asset management firms, we see JP Morgan, they're using it in order to help build bespoke portfolios for some of their clients. And then I believe at Morgan Stanley, they're using generative AI to help their financial advisors be able to tailor advice and aggregate data for some of their clients as well. Okay, so expected value of a constant C is just C, the constant. And so the reason is because when you take a constant to expectation, the constant itself will just always be a constant. And so there's no probability of C being some different type of value. I guess another way of saying that there's 100% probability that our constant C will stay the same. Okay. Another way of saying this is that the probability of C is 100%. I think that's another way of saying it. Okay. So what is R squared? It's another name for R squared. R squared is some type of measurement used in statistical modeling. And so this is something that is commonly used when we try to build predictive models, or models that forecast, make some type of prediction when we're running some type of regression. And so I think another name for R squared is coefficient of determination. And pretty much what the idea is, it's a measure of how well our model fits the data, or how well the dependent variables explain the variance how well the independent variables explain the variance of the dependent variables. And that's kind of a more complex way to think about it. The easiest way I think of is how well does our predictive model actually make predictions, or how well does our model fit the underlying data set, the data distribution. And so when we calculate R squared, you'll see that it utilizes sum of squared residuals. So that's a common measure of error. Distribution, okay, that's good. For any constant c and an arbitrary function g, what is the expectation of c times g of x? So I believe in this case, we can split up the expectation of c times our function x, g of x, into the expectation of c times the expectation of g of x. And the reason we can do that is expectations are linear, and so we can split up the multiplications into each individual expectations and then multiply or take the product of them at the end. And so when we split them, then we have expectation of c times the expectation of our function. And so that means that the expectation of c, as we saw in the previous question, by definition is just equal to the constant. And the expectation of this function, well, I guess it depends on what the function is and what our random variable x is. So, yeah, I think, okay. Okay. What range of values can r squared be in? Let's see, what time is it? Okay. What range of values can r squared be in? What does a high or low r squared mean? So r squared can be, I believe, between 1 and negative infinity. So the way we calculate it, it's 1 minus the sum of squared residuals over the total sum of squares. That's the most common way to think about it. Sum of square residuals is you're taking every single element in our data sets, and then you're also taking our prediction. And you just find the difference between the two, square them, and you could divide that by the number of examples within our data set. Sum of square residuals, that's the sum of squared residuals. The total sum of squares is the exact same. Instead of subtracting by the actual prediction, you're using the average. And so because we're taking 1 minus the sum of square residuals over total sum of squares, the SSR and the TSS, I'll say that for now, those two are both positive numbers since we're squaring the differences. That means that we're always subtracting a positive number, so the highest value we can have is going to be 1. And then if the sum of square residuals is really, really high compared to the total sum of squares, then this r squared can go into infinity, negative infinity. And so when we think about what is a high versus a low r squared, the highest possible value is 1. And what this means is that our sum of square residuals is 0. That means our model is perfectly fitting our data, and there is absolutely no error at all. So with that, a higher r squared means that our model is better able to fit the data compared to a lower r squared, meaning that our model is not able to fit the data as well. And I feel like when we think about it more intuitively, maybe it's how well our model performs compared to just taking the average every time. Because you can also build a statistical model that makes a prediction based on the expectation or the average of our distribution of our data. And we're comparing how well does our prediction or our creative model does better than just taking the average. What is the linearity of expectation? What are its properties? What is an example? So I think with the linearity of expectation, It really comes down to the idea that if you take the expected value of the sum of some random variables, it's just equal to the sum of each of the random variables taken to the expectation. So I think when we think about an example here, the expected value of x plus y, where x and y are both random variables, is just equal to the expectation of x plus the expectation of y. The expectation of the sum of a collection of random variables is simply the sum of the expectations. Okay, right, and then we have constants, then they can just be taken out. But I didn't really remember this formula, so I probably should think about this. This is just saying that the sum of all of our random variables times some constant is just equal to the sum of the constant times the expectation of our random variable. Okay. What is the null hypothesis? So the null hypothesis is something that's commonly used in hypothesis testing. Usually we split up our hypothesis into two different sets, the null hypothesis and also the alternative hypothesis. And usually what's going on is we're trying to find a relationship between different types of variables in an experiment. So the null hypothesis is just usually that there is no relationship at all between these variables, and the alternative hypothesis says that there is a relationship. Independent variable or collection of independent variables. Collection of independent variables has no effect on dependent variables. Okay. What is the basic proof for the linearity of expectations for discrete random variables? Ooh, that might be something I have to come back. I gotta go use the bathroom, so I'm gonna do that, and then I gotta go to class, so I'm gonna sync this and then head to class now. But yeah, good review, and I'll see you in the next one.